Welcome back to Algebra 2. Today's lesson 3.4, solving square root equations. Well, I personally love doing these, so I hope you enjoy doing them as much as I do. All right, so to solve a square root equation, you must first isolate the radical, then square both sides. So for an example, in exercise 1a, we already have our radical isolated. So when you square both sides, we simply get x is equal to 49. B, also the same situation. The radical is isolated. So we have x minus 3, because when you square a square root, they're opposite operations. They cancel each other out. So we have x minus 3 is equal to 25, and then we're going to solve it the same way we'd solve any linear equation, and x is equal to 28. Continuing with this same thought, square both sides, and we get 2x minus 1 is equal to 16. Add 1 to both sides. 2x is equal to 17. Divide both sides by 2. X is 17 divided by 2. So A, B, and C, pretty easy. Don't worry, they get more complicated. But they're still fun to do. All right, moving on to D. Again, at any time, make sure you pause. If you're doing it like I tell you to do it, you should be watching first and then pausing and writing down. So if we take a look at D, the radical is not isolated. So we have a couple of steps to do here first. And if it helps to put those tracks in, feel free. So add 4 to both sides. 3 rad x is equal to 24. Divide both sides by 3, and rad x is equal to 8, and then square both sides. And x is equal to 64. On E, again, we're doing the same way as we would consider doing a linear equation. We're going to add and subtract anything with the radical first. I like my radical on the left side. That's how these are all set up. But if they weren't, you could switch them. Minus 7 from both sides. So you get 2 rad x plus 5 is equal to 6. Divide both sides by 2. And we get rad x plus 5 is equal to 3. And now square both sides. Square, square. X plus 5 is equal to 9. Minus 5 from both sides. And x is equal to 4. Moving on to F. Move the 4 over first. So we get 5 rad 3x minus 2 is equal to 40. Divide both sides by 5. You get rad 3x minus 2 is equal to 8. Square both sides. And we get 3x minus 2 is equal to 64. Add 2 to both sides. 3x is equal to 66. Divide by 3, and x is equal to 22. So get equal sign. Sorry about that. So far so good. These do not require all that much skill at this point. So write down what you need to before moving on to exercise 2. We're going to follow the same rule. We're going to isolate that square root, even though, remember, the 2 is underneath that square root. So here we're going to divide both sides by 3. So you get rad x divided by 2 is equal to 5. And now square both sides. and you get x over 2 is equal to 25. And now to get rid of the 2, we multiply both sides by 2. 2's cancel, and x is equal to 50. So here's our answer. Very similar to the problems that we did in exercise 1. Okay, moving on to exercise 3. So here we're going to spend a little time graphing these. So a more complicated scenario arises when a square root expression is equal to a linear expression. The next exercise will illustrate both graphical and algebraic solutions. So exercise 3, consider the system of equations below. So the first one is a square root problem equation, and the second one is a linear function. So positive 1, I'm going to do linear first. Start at 1, up 1 over 1. Draw the line. Looks like so. And give it a label. This is y equals x plus 1. The second equation is a square root problem. And again, equation, you're going to put this right in your calculator. Don't flip out by it. So let's pick a nice color like blue. And this one tells me it's translated -3. So here and here and 6, 3. So this one looks like this. And this is y equals rad x plus 3. So as we can see, here is our solution. One solution, and this is the solution 1, 2. Solve the system of equations graphically using the grid. So it says to solve this, so make sure you are putting down what your answer is. So the solution is 1, 2. Remember what this means. X is equal to 1, y is equal to 2. There's only one value of x. So B says now solve the system algebraically. So let's see what happens when we set these two equal to each other and we solve this algebraically. So we get notice we have y equals, so we can set them equal to each other and solve it. Now, because the radical is already isolated, we can just square both sides. So we get x plus 3 is equal to x squared, remember what this means, x plus 1 times x plus 1, which when we multiply that becomes x squared plus 2x plus 1. The only way we can solve a quadratic is set it equal to 0 algebraically. So we're going to subtract x and -3. I'm going to do it in one step. These cancel to 0, and I get x squared minus x minus 2, and I'm going to put the equal 0 in the back because that's the way I like it. I'm sorry, this is a plus x because a positive 2 minus a 1x is a positive 2. And I'm going to simply factor this, and this becomes x plus 2, x minus 1 equals 0. So my solutions or my zeros, my zeros of my function are my solutions to my equation. So x is equal to -2 and x is equal to +1. Now this is telling me, C, I'm getting ahead of myself. C says, why does your answer from part A contradict what you found in part B? Because part A I found only 1 0. So I'm going to write in part A, we found only 1 0 at x equals 1. And in part B, we found two solutions. Whoops, reset. Two solutions at x equals 1 and x equals -2. So one of these is not going to work. So as you can read on here, and I'm kind of going to just read this to you, and it says when we solve a square root function that we force into a quadratic equation, it results in two solutions, and that's exactly what just happened. All right. When we start with the square root problem that ends in a quadratic, it forces it into two solutions. But we know that a square root function, when it's a linear function like this one was, can have at most one zero. So the second zero is called extraneous, and then we reject them. So in this case, you would actually have to go back and check to see which one of these is the root, and you can do it by using your calculator, because you can reject it without actually doing the algebra. But you have to make sure you reject one of them. All right, so let's look at a few examples of these in exercise 4, and then we're done for today. So hopefully we can get through these rather quickly and not spend more than, let's say, 20-25 minutes on this video. All right, so looking at 4a, the radical is already isolated, which is nice. So we're just going to square both sides. So 2x minus 3 is equal to, and instead of saying x minus 3 squared, I'm going to write it out as x minus 3 times x minus 3 because it makes it a little bit easier to factor it then. I'm sorry, to multiply it then. So x squared minus 3x is minus 6x plus 9. I'm going to slide these two over by changing the sign. Again, I'm doing it in one step. You can do it in two. So these cancel, and I get x squared minus 8x plus 12 equals 0, which is very nice because it does factor. So it factors into two numbers that multiply to 12 but add to 8. I know the signs are the same, and I have minus 6 and minus 2. So my answers are positive 6 and positive 2. But like I said, we know that one of these is not right. So we have to check them. So we're going to go back. Let me just bring it up a little bit. We're going to go back now and give it a check. And usually how I check is I kind of do this. And I say rad 2 times 6 minus 3 is equal to 6 minus 3. So I get radical 12 minus 3, which is 9, is equal to 6 minus 3, which is not equal to 9. Okay, I knew something was wrong here. Duh, square root of 9 is equal to, something was wrong. Square root of 9 is equal to 3. So I know 3 is equal to 3, and this one does check. So I know that x equals 6 is a solution or a 0 to my function. And the reason I kind of realized that was wrong is because when I looked at x as 2, just quickly, and I said to myself, 2 times 2 minus 3 has to equal 2 minus 3. And 2 minus 3 is negative 1. So no matter what my radical is, I know it's never going to be a negative. So this one turns out to be 4 minus 1, which is 1. So I know 1 does not equal negative 1. So this one I reject. Right? So basically what I do when I reject it is I put an X through it and I write reject. All right, one of them should check. All right, now taking a look at B, we're going to kind of do the same thing here. So in this case, the radical is not isolated. So let's add 2 to both sides. and I get 2x plus 2 is equal to radical x plus 6. And if you don't like the radical on the right, you can flip-flop them. But as soon as we square both sides, everything gets happier. So again, I'm going to write this as 2x plus 2 times 2x plus 2 is equal to x plus 6. I'm going to multiply this out and get 4x squared plus 4 plus 4 plus 8x plus 4 is equal to x plus 6. I'm going to bring these over. Oops. These cancel to 0. Here I have 4x squared plus 7x minus 2 is equal to 0. And we're going to factor this one. You can use the box method if you need to, but when you factor these, you get 4x and x and minus 1 and positive 2. Hopefully that's not the hard part of this problem. So you get 4x minus 1 equals 0. Add 1. I'm just doing this one the long way because it's going to end up to be a fraction. And x is equal to 1 over 4. And here I have x is equal to negative 2. So these are my two roots that I have to check now. So what I'm going to do is do this. 2x is equal to rad x plus 6 minus 2. So keeping that there, now I'm going to slide this down and check them. So we're going to check, let's check the negative 2 first because it's just easier. So we're going to say 2 times negative 2 is equal to rad negative 2 plus 6 and then minus 2 at the end. So is negative 4 equal to the square root of 4 minus 2? Is negative 4 equal to 2 minus 2? And the answer is no, they're not equal to each other. So I know that this one, I'm hoping, is rejecting. So I'm going to check the next one. And just because you have a fraction, remember, you just have to show the check. So 2 times 1/4 is equal to the square root of 1/4 plus 6 minus 2. And you're going to put this whole thing into your calculator, and you're going to find out that this is the same thing as a half is equal to the same thing as a half, and it will check. That's what So I know this is my solution to my equation. So good, kept it under 20 minutes. I'm always time conscious. So until I see you again, always make good choices, be safe, and I'll see you next time.